Hello again. We're going to be talking about truth tables again. We've been talking about truth tables quite a bit. This time we're going to be talking about truth tables with regard to arguments. You should recognize the syllogistic form of these particular arguments. So what we've done so far is we've looked at the truth tables for each connective. We've looked at truth tables with regard to sentences, and we've looked at truth tables in comparison with one another. Now we're going to be doing truth tables for arguments to determine validity and invalidity. Okay, so let's start over here on this side of the board. The argument that I've written is that if all geese are white, then Jimmy is skinny. All geese are white and Socrates likes Jell-O. Therefore, Jimmy is skinny. So this is our argument. We have two premises and we have a conclusion. The conclusion, again, is marked out by the three dots, meaning therefore. And what I've done is I've translated the propositional content of these premises in the conclusion in this form. So G stands for all geese are white, J stands for Jimmy is skinny, and S stands for Socrates likes Jell-O. So if all geese are white, then Jimmy is skinny. All geese are white and Socrates likes Jell-O, Jimmy is skinny. Okay? So what we're going to do is we're going to represent this with our truth table for G and S. So we're going to do a truth table for G and J, and we're going to do one for G and S. And true, true, false, false. Remember, this is just sort of what we've been doing all the way through the course on truth tables. Great. So we know that when the antecedent is true and the consequent is false, which occurs in the second line of our truth table, that it's false, and every other line is true. Right? This is for the material conditional. For the conjunction, it's only true when both are true, true and false and all the rest. And then J is just going to take the truth value for itself because there's no operation acting on its truth function. So what we'll find is that this argument is valid. Why is it valid? Well, when we're looking for the validity and invalidity of arguments, what we're looking for is one line that shows that the argument is invalid. And if that line doesn't exist, then it's valid. And that line that we're looking for is one in which every truth operator is true, but the conclusion is false. And this is because the validity of arguments works very much like the truth functionality of our material conditional. Right? The material conditional is false when the antecedent is true and the consequent is false. Likewise, an argument is invalid when its premises are true, but the conclusion is false. It's the same principle. It's a logical principle. It's the intuition that we're trying to capture with this form of logic. So what we'll notice is that there's only one line where both of the premises are true. And just as a sort of side note, in notation, a single slash notes the difference in premises, and a double slash indicates the conclusion. Okay, so there's only one line where both of the premises are true, but it turns out that the conclusion is also true. Now there's a whole bunch of other lines. There's a line where both the premises are false, the conclusion is false. That's okay, that can still be valid. Where one premise is true, where one premise is false, and then different conclusion truth values. Again, that doesn't break our conditionality for validity. Therefore, this argument is valid. Now, again, what we're doing with truth tables and arguments is we're looking for a line that has all true premises and one false conclusion. And if this exists, then the argument is invalid. We're going to see that that's the case over here with this argument. So again, the argument is if the flavor is grape, then Socrates likes Jell-O. Socrates likes Jell-O, therefore the flavor is grape. I've translated the sentences into propositional logical form. F being the flavor is grape, S being Socrates likes Jell-O. So we're going to have the same truth table here. It's just the regular material conditional. So true, false, true, true. And then if we were to write this out in truth table form, true, true, false, false, and true, false, true, false, right? This is just the way in which we break down every single truth table with two predicate variables. Now the truth function of just s by itself is already written here, which is true, false, true, false. And then likewise for f, it's written here, true, true, false, false. So true, true, false, false. Here's a line where all of our premises are true, right? Our premises are marked together by this slash, and the conclusion by the double slash. And there can be multiple premises too. We can have 3, 4, 5, infinitely many premises and one conclusion. So here's one line where all of our premises are true, but the conclusion is also true, so that's okay. Again, we're looking for a line where all the premises are true. Line 3 also has that. Uh-oh, the conclusion is false. So what we've done is we found a line in which all of the premises are true and the conclusion is false. Therefore, this argument is invalid. Okay. And so this is how we use truth tables to analyze the validity and invalidity of arguments. This is a quick video. In the next one, we're going to be moving on to argument forms, so modus ponens, modus tollens, etc. This stuff will be tested. Again, what you should be looking for, I can't repeat it enough, is when testing arguments with truth tables, look for the one line in which all of the premises are true and the conclusion is false. If that line doesn't exist, then the argument's valid.